In this video, we're going to solve exponential and logarithmic equations. We're going to use like bases to solve exponential. We're going to use logarithms to solve exponential equations. We're going to use a definition of a logarithm to solve logarithmic equations. We're going to use the one-to-one property of logarithmics to solve logarithmic equations. And then we're going to solve some applied problems involving exponential and logarithmic equations. So the first thing we're going to do is a warm-up, and this is from our last section, our last video. We're going to use the laws of logs to rewrite these as sums and difference, in other words, expand out. So this exponent and this exponent will be multipliers. Since this is multiplication, it'll be a plus, so log of a. 3 will come out front of x, plus 2, the log based a of y. Since the only one that has the exponent is the x, and this is a division, this will become the 2 the log based b of x minus the log based b of y. This becomes the natural log of 5 plus the natural log of a minus the natural log of 4 minus the natural log of b, because a and b are multipliers and they're both in the denominator. So of course we know from our last video that these will bust apart with a plus until I pull that negative all the way through. Similarly, this will be the log of 10 plus 2 the log of x minus 3 the log of y minus the log of z. But we know that this equals 1, so we can rewrite this as 1 plus 2 the log of x minus 3 the log of y minus the log of z. This very last one, this is the same thing as a log based a of a to the 6th, b to the 8th, a to the 2, b to the 5, all raised to the 1/2, which is the same thing as a log based a of, and I'm going to reduce that to a to the 4th, and I'm going to reduce this to b to the 3, raised to the 1/2, some algebra here. Now I'm going to rewrite this as a log based a of a raised to 4 divided by 2, b to the 3 divided by 2, which is the log based a of a squared over b raised to the 3/2. And now I'm ready to expand this out. So this is 2 the log based a of a minus 3 over 2 the log based a of b. But this is just 2, so this becomes 2 minus 3/2 the log based a of b. There's all of that in its glory. We have this rule, and we've talked about this in class already, that if we have a to the x is equal to a to the y, this happens if and only if these exponents are equal. So if I'm asked to solve an exponential equation, the first thing I'm going to try to do is get my basis to be the same to solve so I can set my exponents equal. So this is 3 to the x. 81, well, 3 squared is 9, so that means 3 to the 4th must be 81, so this is 3 to the 4th. That tells me that x is equal to 4, and there's my answer. This is base 2, this is base 4, so I'm going to write this as 2 to the x plus 3. Base 4 is 2 squared, but it's raised to the 2x plus 5. So this tells me I have 2 to the x plus 3. I'm going to use the power to power rule. That means that this 2 is going to distribute onto both of those 2, giving me 2 to the x, 2 raised to the 4x plus 10. That means that x plus 3 must be 4x plus 10. Moving the x's to the left and the non-x's to the right, so I'm going to have negative 7 is equal to 3x. It means x is equal to negative 7/3. And there's my answer for that one. Here I have a bunch of things going on, so I'm going to write this as a factor, a multiple of 3. I'm going to write this as a multiple of 3. So this is 3 squared, or 3 cubed, excuse me. 27 is 3 cubed. 3 raised to the 5x, and then 3 squared raised to the x squared. So this becomes 3 cubed is equal to 3 to the 5x multiplied by 3 to the 2x squared. So I have 3 cubed is equal to 3 to the 2x squared plus 5x, which tells me that 3 is equal to 2x to the squared plus 5x, which is a quadratic. And we are going to solve this as 2x squared plus 5x minus 3 is equal to 0. This factors into 2x and x is equal to 0. 3 goes here, 1 goes here, plus and a minus. So I get x is equal to 1/2 or x is equal to -3. So those are my two choices there. And then this, I'm going to rewrite this 64. So I have 4x squared plus 4x is equal to, since this is 1 over 4 to the third, this becomes 4x squared plus 4x is equal to 4 raised to the -3 using the rules of exponents. Because I know that if I have a to the -n, this is 1 over a to the n. So then this becomes x squared plus 4x is equal to -3. X squared plus 4x plus 3 is equal to 0. This factors into x plus 3 and x plus 1. And I get x is equal to -3 and -1. All right. We talked about this last time as well. It said that if my log-based a of m equals a log-based a of n, then m has to equal n. We talked about this in class. So there's no way that I can make these the same base. So what I'm going to do is I'm going to take the log or natural log of both sides. It's really up to you which one you like. I like the natural log. So the ln of 84x is equal to the ln of 70. Then I'm going to use the power rule and bring that out front. And so I'm going to have x, the natural log of 84, is equal to the natural log of 70. Since the natural log of 84 is just a multiplier, it's just a number, I can divide both sides by it. So I have x is equal to the natural log of 70 divided by the natural log of 84. And I can leave it just like that. Similarly, I'm going to do the same thing. I'm going to do the natural log of 15x is equal to the natural log of 30. Now, I want to say that you can use log. I just like writing natural log. It's left to right. So I have x, the natural log of 15 is equal to the natural log of 30, bringing that x down out front as an exponent, dividing both sides by the natural log of 15. I have the natural log of 30 is equal to the natural log of 15, and that is my answer. I'm going to obviously do here the natural log, so I'm going to do the natural log of e to the -t is equal to the natural log of 0.04. So we have -t down out front as the exponent. It's going to come down out front. And so that is just -t because I'm left with the natural log of e, which is 1. So t is equal, -t is equal to the natural log of 0.04. So t is equal to the negative natural log of 0.04. Similarly, I'm going to do the same thing here. I'm going to take the natural log of 5x plus 2 is equal to the natural log of 1 minus x. That x plus 2 comes down out front as a multiplier, the natural log of 5. And the 1 minus x also comes down out front as the multiplier. I'm going to distribute the natural log of 5 through, so I have x, the natural log of 5, plus 2, the natural log of 5. On the other side, I'm going to do the same thing. So I'm going to have the natural log of 4 minus x, the natural log of 4. Anything that has an x attached to it will stay on one side. Anything that does not have an x attached to it will move to the other side. So this becomes x, the natural log of 5, plus x, the natural log of 4, is equal to the natural log of 4 minus 2, the natural log of 5. Factoring x out of the left-hand side, I get x, the natural log of 5, plus x, the natural log of, x, the natural log of 5, plus the natural log of 4. Natural log of 4 minus 2, the natural log of 5. And then I'm going to divide both sides by this because it's just a number. So x is equal to the natural log of 4 minus 2, the natural log of 5, divided by the natural log of 5 plus the natural log of 4. And if I am inclined, I can bring this together. If I wanted to, I probably wouldn't. But if I wanted to, I'd write this as the natural log of 4 divided by 25, because that's what that is, divided by the natural log of 5 divided by 4. And you're like, oh, do the natural logs cancel? And the answer is no. And you're like, oh, can I write it? It's the same thing. And the answer is still no. So that's as good as that gets. And then the very last one. Now with this very last one is what we're going to do is we're going to rewrite this as e to the x plus e to the negative x minus 4 is equal to 0. And I'm going to go ahead and rewrite this as e to the x plus 1 over e to the x minus 4 is equal to 0. Now I'm going to multiply everything by e to the x. I'm going to get e to the 2x, because I have x plus 1 minus 4e to the x is equal to 0. And now I'm going to rewrite this as e to the 2x minus 4. There should be a minus 4e to the x plus 1. Yep, is equal to 0. And let u equal e to the x. That means u squared is equal to e to the 2x. This is reducible to a quadratic, so this becomes u squared minus 4u plus 1 is equal to 0. And now we have to use a quadratic equation. So u is equal to negative b, which is 4, plus or minus the square root of b squared. So negative 4, the quantity squared, minus 4 multiplied by 1, divided by 2. So u is equal to 4 plus or minus the square root of 16 minus 4, which is square root of 12 over 2. U is equal to 4 plus or minus the square root. Well, 12 is the same thing as 4 multiplied by 3, so 2 root 3 all over 2. Factoring out a 2, I'm going to get u is equal to 2 plus or minus the square root of 3 all over 2. So u is equal to 2 plus or minus the square root of 3. But we're not solving for u, we are solving for e to the x, which is equal to u, which is equal to 2 plus the square root of 3, and e to the x is also equal to 2 minus the square root of 3. Now with each one of these two, this one and this one, I'm going to multiply both sides by, or actually take the natural log. It's not multiplication, it is the natural log of both sides. So starting with this one, I have the natural log of e to the x is equal to the natural log of 2 plus the square root of 3. That means x is equal to the natural log of 2 plus the square root of 3. Same thing here. I'm going to have the natural log of e to the x is equal to 2 minus the square natural log of 2 minus the square root of 3. So x is equal to the natural log of 2 minus the square root of 3. Whew, that was a lot. All right. So now, when we are solving logarithmic equations, now we're going to solve the logarithmic equations. What we want to do is, if we can, turn it back into its equivalent exponential and solve that way. If we can't, let's put logs on one side, logs on the other, same base. Then the log based a of m is equal to log based a of n, if and only if m is equal to n. Now on this, you do have to check, and the reason is because we know, since this strictly has to be at 10 plus 3x strictly has to be greater than 0, we can come up with solutions algebraically, but they do not check. So these are ones we have to check. All right, so I'm going to turn this into its equivalent exponential, and I'm going to have 2 to the 5th is equal to 10 plus 3x. So I'm going to get 2 to the 5th, which is, let me see, 2 to the 3rd is 8, 4 is 16, 2 to the 5th is 32, is equal to 10 minus or plus 3x. Subtract 10 from both sides, and I'm going to get 22 divided by 3 is equal to x. And I just need to check to make sure when I put this in right here, it will not be a negative exponent or a negative value, and it will not. On part B, what I'm going to do is I'm going to bring this together so I can turn it into its equivalent exponential. So this is going to be the log of x divided by x plus 3 is equal to negative 1. Now I'm going to turn it into its equivalent exponential. Since it's a common log, it's 10, base 10, so 10 raised to the negative 1 is equal to x over x plus 3. Multiplying both sides by x plus 3, I'm going to get 10 to the negative 1. X plus 3 is equal to x. Now I'm going to go ahead and distribute, so I'll have 10 to the negative 1x plus 3 times 10 to the negative 1 is equal to x. Since 10 to the negative 1 is 0.1, this is really 0.1x. Plus 0.3 is equal to x. 10 to the negative 1 is 1 over 10, which is equal to 0.1. I'm going to subtract 0.1 from both sides, so I have 0.3 is equal to x, so 0.9x. I'm going to divide both sides by 0.9, so 0.3 divided by 0.9 is equal to x. So this is 1/3 is equal to x. And now I just have to make sure when I put this back into here, it doesn't make a negative. When I do the natural log of 1/3, it's fine. 1/3 plus 3 is not negative, so that is also okay. So now I'm going to take a look at this one. So this is addition, so it becomes multiplication. So the log base 4 of x plus 3 multiplied by x minus 3 is equal to 2. So I'm going to rewrite this as 4 squared is equal to x squared minus 9. That's not an eraser. That's still not a good eraser. Now that's an eraser. Minus, erase that one more time. Minus, for the love of gophers, try this one more time. Minus 9. That was painful. I'm going to add 9 to both sides. 16 plus 9 is 25 is equal to x squared. That means x is equal to plus and minus 5. Now, if I put in plus 5 here and here, I have 5 plus 3. This is greater than 0, so we're good there. And I have 5 minus 3, which is greater than 0, so we're good there. However, when I do negative 5 plus 3, this is less than 0, so it's not going to work. So my only solution is positive 5. When x is equal to negative 5, this is extraneous. So it is not a true solution. So the only solution I have is x is equal to 5. This is where I said you need to check. Okay, now for this one, I'm going to bring these two together with a multiplication, and I'm going to make this go back up as an exponent. So this is the natural log of x plus 8 multiplied by x minus 1, which is equal to the natural log of x squared. Now, since we have the natural log on each side, one natural log is equal to an additional natural log. That means I have x plus 8 is equal to x minus 1, x plus 8 multiplied by x minus 1 is equal to x squared. This does not, by the way, cancel out natural logs. We are not canceling out natural logs. We are using the properties of logs that says if I have the log based b of m is equal to the log based b of n, then m has to equal n. That's what I'm using. I am not counting out logs. I just want you to be aware of that. All right, so moving on, we're going to multiply this out, and I'm going to get an x squared plus 7x, I believe. Let me erase that. I wanted to write 8. 7x minus 8 is equal to x squared. Subtracting x squared from both sides, I get 7x minus 8 is equal to 0. So 7x is equal to 8, so x is equal to 8/7. And I just need to make sure that when I put 8/7 back into x plus 8, that it is bigger than 0, and it is. So 8/7 plus 8 is greater than 0, and also 8/7, which is bigger than 1 minus 1, will also be greater than 0. So it will not produce an extraneous solution, so this is my one and only final solution. Now on this one, I'm going to go ahead and bring this together on the left-hand side. This is the log base 3 of x multiplied by x plus 3, and on the right-hand side, I'm going to get the log base 3 of 2x plus 3. So I have x plus 3 is equal to 2x plus 3. So I'm going to get x squared plus 3x is equal to 2x plus 6. Bring everything to the left-hand side. I'm going to get x squared plus x minus 6 is equal to 0. This factors into x plus 3. X minus 2 is equal to 0, so x is equal to negative 3, and x is equal to 2. Now I have to check this. In the here, that's cool. Like right here, we're cool. This is one I have to check in, and this is one I have to check in. So I have negative 3 plus 3. This is not greater than 0. It actually equals 0. So this one does not check. So this actually equals 0. So I know that this one is extraneous, and then I have 2 plus 3, which is greater than 0, so that one checks. That is my only solution. All right, again, what I'm going to rewrite this as is e to the x minus 2 plus e to the negative x is equal to 0. E to the x minus 2 plus 1 over e to the x is equal to 0. Multiplying everything by e to the x, I'm going to get e to the 2x minus 2e to the x plus 1 is equal to 0. This factors, if we let u equal e to the x, u squared is equal to e to the 2x. So I get u squared minus 2u plus 1 is equal to 0. So I get u minus 1, the quantity squared, is equal to 0. So u equals 1. That means e to the x is equal to 1 because we're solving for x, which means x is equal to the natural log of 1, which means x is equal to 0. Boom. All right, so how would we solve this? Well, for this first one, we know this is this exponent raised, so e raised to the 2 is equal to this. So turn it to equivalent exponential, we have e squared is equal to the natural log of x. And the only time that works is if I have, let's go ahead and turn this into its equivalent exponential one more time, is if I have e raised to the e squared is equal to x. And so there you have it. X has to be e raised to the e squared. For number 2, we're going to do is we're going to turn this into its equivalent log form. So it is the log based x of x cubed over 100 is equal to the log of x. Now I'm going to expand this out on the left-hand side. So I have the log based x of x cubed plus the log based x of 100 is equal to the log of x, common log of x. So this becomes 3 plus the log based x of 100 is equal to the log of x. I'm going to use the change of base on this. So I'm going to have 3 plus, and the change of base is the log of 100 over the log of x, which is equal to the log of x. Now I'm going to go ahead and, let me see. This is 3 plus the log of 100 is 2 over the log of x, which is equal to the log of x. I'm going to multiply everything by log of x. So I'm going to have 3 the log of x plus 2 is equal to the log of x, the quantity squared. This is not the log of x multiplied by the log of x. This is not the log of x squared. It is a log multiplied by the log, so it's log squared. So this is the log of x, the quantity squared, minus 3, the log of x plus 2 is equal to 0. Now I'm going to let u equal the log of x. That means u squared is equal to the log of x, the quantity squared. So this is reducible to quadratic, so this becomes u squared minus 3u plus 2 is equal to 0. So u minus 2, u minus 1 is equal to 0. So I get u is equal to 2 and u is equal to 1. That means the log, because that is u, log of x is equal to 2, and the log of x is equal to 1. That means 10 squared is equal to x, and 10 to the 1 is equal to x. And those are my two solutions. And if I put that back in, yep, we are good. I don't have to worry about trying to take the log of a negative number. All right, here is my last and final one. So I'm going to multiply everything by this. And so I'm going to have e to the x plus e to the negative x is equal to 3 e to the x minus e to the negative x. So e to the x plus e to the negative x is equal to 3e to the x distributing through minus 3e to the negative x. Multiplying everything by an e to the x to clear out, because remember e to the negative x is 1 over e to the x. And so if I multiply both sides by e to the x, I'm going to get e to the 2x plus 1 is equal to 3e to the 2x minus 3. I'm going to subtract e to the 2x from both sides, and I'm going to add 3 to both sides, so I'm going to get 4 is equal to 2e to the 2x. Divide both sides by 2, so I get 2e. 2 is equal to e to the 2x. I'm going to take the natural log of both sides. The natural log of 2 is equal to the natural log of e to the 2x. So the natural log of 2 is equal to 2x e, the natural log of e, by bringing this down out front as a multiplier. But the natural log of e is just 1, and so I get the natural log of 2 is equal to 2x. Divide both sides by 2, I get 1/2. The natural log of 2 is equal to x. And that is it for this video. Now you're thinking, wow, that was fast. Yeah, you probably want to pause this, rewind stuff, and this is why I don't lecture in class, is because I'm fast. And I could lose you, and I don't want to. So pause, rewind as needed. Bring your questions to class. We'll see you in class.